Hello and welcome to our first lesson of GCSE Triple Physics on seismic waves. And our first lesson today is we're going to focus on S waves, P waves, and surface waves. Now, what I need you to do is get your date, title, keywords written, and then answer the 4 do now questions. So, to do so, just hit pause. Right, our answers for the do now then. So, name the 6 organelles in a plant cell. We've got the nucleus, which is our control center, and it also contains DNA. We've got the cell membrane, which controls what enters and exits the cell. We've got cytoplasm, which is the site of reactions in our cell. We've got the cell wall. Think of a wall of a house, gives it structure. The cell wall does the same thing, provides structure to the plant cell. We've got the vacuole, which stores food and water. And finally, we've got the chloroplast, which carries out photosynthesis. Question number 2, name the 4 chambers of the heart. Left atrium, left ventricle, right ventricle. Name the 3 atomic particles. 3 atomic particles just means what is in an atom. Protons, neutrons, and electrons. And finally, write the equation for photosynthesis. Carbon dioxide plus water plus sunlight gives us glucose plus oxygen. If you need to get those correct answers in or do any marking, just hit pause now. So, our naughty words for today's lesson. We are going to compare the properties of the 3 seismic waves. And our learning journey has got 3 steps. Okay, first thing we're going to do is define the terms longitudinal and transverse wave. That's a bit of a recap. We're then going to outline the structure of the Earth. And then finally, we're going to compare the properties of the 3 seismic waves. And just again to remind us, along the bottom, our keywords are transverse, longitudinal, crust, mantle, and core. Now, before we start looking at this learning journey then, let's just really link this topic to real life. And seismic waves has got everything to do with earthquakes. Okay, a seismologist is somebody that studies earthquakes. A seismometer is a machine which studies the strength of earthquakes. And seismic waves is all about the waves linked to earthquakes. Now, even though we're talking about waves linked to earthquakes, they still fall into the category of waves that we have studied in year 7, 8, and 9. And our first wave that we're talking about is a longitudinal wave. And when it comes to a longitudinal wave, I want you to think of, on Toy Story, you know, the dog with the slinky? Think of the slinky itself. That slinky moves back and forth, okay? It vibrates back and forth. And that is an example of a longitudinal wave. Now, you will notice in that yellow box, I've got the vibrations are in the same direction as the direction of travel, and longitudinal equals back and forth. Now, I need you to write this down, as this could be worth up to 2 marks in exam. So I want you to hit pause now. Our second type of wave is a transverse wave. Okay, so a transverse wave, if our longitudinal goes back and forth, our transverse wave goes up and down. Okay, and once again, we've got a key definition we can learn. The vibrations are at right angles to the direction of travel, and transverse equals up and down. So what is in that yellow box, I need you to write down. So hit pause now. And there we have it. Okay, we have defined the terms longitudinal and transverse wave. So now it's time for us to move on and look at the structure of the Earth. So first thing, our structure of the Earth is made of 4 separate layers. We've got the crust, the mantle, the outer core, and the inner core. Now our crust is what we're standing on. It's a solid. Easy way to remember which one's the crust. Think of a slice of bread. The crust is on the outside. The mantle. Now if the crust is a solid, the mantle is what we call a semi-solid. Okay? And what this means is slow or flows very slowly. Nice example of a semi-solid. I want you to think of ice cream, Nutella, peanut butter, all the nice foods. Imagine lifting a spoon of that up, okay, and turning the spoon upside down. All 3 of those foods are going to flow very slowly off the spoon, but they're not going to flow easily like a normal liquid. Now, the mantle flows in a very special way though, okay? It flows due to, and a really key term here, so I'm going to put it in bold for you, convection currents, okay? Our next layer is the outer core, okay? And the outer core is a liquid. And the outer core is made of 2 metals you will find on the periodic table. It's made of molten iron. Molten's just another way of saying liquid or melted. And nickel. So far, solid crust, semi-solid mantle, liquid outer core. Now, our last thing then is the inner core is actually solid. Okay? And the key reason why this is because all of the mass of the Earth is squashing particles together, and they are so closely packed together they become a solid. Okay, they become one. There is no space for particles in the center of that Earth to be able to flow. Just like the outer core, though, it's made of iron and nickel, and it's the hottest part of our Earth. And the reason for this is that the inner core is radioactive, okay? And it releases heat. Now, do you remember that bold term, the convection currents? These are caused by that release of heat, okay? So there's a nice summary. Now, throughout these videos, there is no pressure for you to write notes down. If you feel like you want to write these down or draw a diagram of the Earth, that's fine. All you need to do is hit pause at any point in the video. Now, our first review activity is we're going to fill in the blanks, and this is about outlining the structure of the Earth. First thing I need you to do is put the subtitle, Review 1, and fill in the blanks. I'm going to give you time to do that now. Now, there's a success criteria which I want us to follow for filling in these notes. First thing, we are going to write out all of the notes. We're not just going to write in the missing words. This is because I really want you to have detailed notes to look back on. Second thing is when you are filling in these gaps, so you know which keywords you've added in and where they were so you can mark the answers, I'd like you to highlight, underline, or write the missing words in a different colour. So I need you to hit pause and complete this activity. Here we got the answers then. So let's go through these together. The Earth's structure is split into 4 parts: the crust, mantle, outer core, and inner core. The outermost layer is called the crust and is a solid. Next is the mantle. This layer is known as a semi-solid and flows very slowly due to convection currents. The next layer is called the outer core and is made up of molten iron and nickel. Finally, at the center of the Earth is the inner core. The inner core is a solid ball of iron and nickel. The inner core releases large amounts of heat because it is radioactive, leading to the convection currents in the mantle. If you need to pause it to tick your answers and maybe correct some, I'm going to give you a chance to do that now by hitting pause. Now, our second review. So first thing we need to do, subtitle, review 2, what layer am I? So I'm going to give you time to write that in, underline it. Now, success criteria for this, you only need to write the name of the layer each statement links to. And in brackets, the number tells you how many layers are the answer. So for example, question number 1, I am a slow-moving semi-solid. You only need to write one of crust, mantle, outer core, or inner core. But for question 3, for we are both solid, you need to write 2 of those layers. So I need you to hit pause and complete those questions now. Okay, answers then for these review 2. Question 1, I'm a slow-moving semi-solid. That's the mantle. Question 2, I'm the part of the earth I stand on. That's our crust. Question 3, we are both solid. That's the crust and the inner core. Question 4, we are both made of iron and nickel. That gives me the outer core and the inner core. Question 5, I am the only layer which is a pure liquid. That's the outer core. Question 6, I'm the only layer which is radioactive. That's the inner core. And finally, I am the largest layer, and that is the mantle. Now we're 2/3 of the way through our journey. If you need to pause this quickly now to mark your answers or get the correct ones in, you can do so now. And our last part of our learning journey, we're going to compare the properties of the 3 seismic waves: S waves, P waves, and surface waves. Now our first type of wave are S waves. They are transverse. Okay. Now our transverse waves, vibrations are at right angles, or really simply up and down. Now in terms of speed, relative to the others, our S wave is medium speed, and our S wave is able to travel through solids. And this means it can travel through the mantle. Okay? But it is stopped by the outer core. We've got our P waves. Our P wave, the longitudinal wave. Longitudinal, very tough one to spell, that is. Now our P wave, fastest out of all of them. And our P wave is able to travel through solids, so it can travel through the mantle, but it can also travel through liquids, which means it can travel through the outer core. And because it can travel through that outer core, the other solid it can go through is the inner core. Okay, so if you picture our structure of the Earth now, and maybe it's best for me to just go back, I want you to think our S waves get stopped by our outer core. Okay, they just get absorbed. Whereas our P waves go through the mantle, through the outer core, through the inner core, and they can go back through all the way to the other side. Now our last type of wave, a surface wave. Now, like a P wave, they are longitudinal. Spelled it right this time as well. But surface waves are very slow. They are the tortoise of seismic waves. Now, our surface wave cannot travel through any of the structure of the Earth. Like the name suggests, they only go on the surface. Now, if you've been making detailed notes throughout this, feel free to hit pause now, okay? And you can summarize this. Otherwise, we're going to go on to our third review activity of the lesson. Okay, review 3, subtitle, the 3 seismic waves. Now, we should be really good at this now. I need you to be writing down your subtitle for review 3. And again, it's the same success criteria for filling in the blanks. Okay, you need to write out all of the notes, and any missing words you fill in, I need you to highlight, underline, or write the missing words in a different colour. So I need you to hit pause now and complete that activity. Review 3 then, the answers. There are 3 seismic waves: S waves, P waves, and surface waves. Only S waves are transverse waves, whilst P waves and surface waves are longitudinal. S waves can travel through solids only, P waves can travel through solids and liquids, and surface waves travel on the surface. P waves are the fastest, followed by S waves, and then surface waves are the slowest. So if you need to do some marking or fill in the correct answers, hit pause now. Now, before we go on to our last part of the lesson, our final review, I just want to talk about where the names S and P come from. And this is all about the speed of the wave. Okay, so our P wave is the fastest, which means it's going to arrive first. The P wave stands for primary. It's the first wave that ever arrives from an earthquake. Our S wave arrives second. You think it's the second fastest, and that means that we call it a secondary wave. Now, our final review activity. Again, the subtitle is the 3 seismic waves. So I'm sure already that we're on top of this, we're doing our subtitles, and we're taking real care in our work. And we are doing well to stay with me all of this time. This time, you just need to answer the following questions, and they don't need to be in full sentences. This is as fewer words as possible, using the marks in brackets to tell you how much you should be writing. Each one of the answers is a name of a wave. So I'd like you to hit pause right now and complete this final review activity. Review number 4 then. Well done for getting here. Now, question number 1, the S in S wave stands for secondary. The P in P wave stands for primary. Question 3, the 2 seismic waves that are longitudinal are P waves and surface waves. Our slowest seismic wave, the tortoise of the seismic waves, are surface waves. Question 5, the 2 seismic waves that travel through the inside of the Earth's structure are P and S waves. And the only seismic wave that can pass through the outer core are the P waves. Remember, surface waves can't even get on the inside of the Earth, and our S waves get absorbed by that outer core. So just make sure you've got those answers in. I want to thank you for working so hard and getting to the end of this online lesson. And I hope that you've enjoyed it and that you're looking forward for the next lesson on seismic waves. So thank you.